In the shadow of Geneva, underneath the outer layer of the Earth, lies quite possibly of mankind's most significant accomplishment and an image of our persevering journey for information. The enormous Hadron Collider, LHC. This enormous particle accelerator exemplifies the highest level of engineering and scientific achievement. The LHC isn't simply a machine. It addresses the finish of many years of exploration and development, intending to open the most slippery insider facts of the universe and investigate the principal building blocks of the real world. Worked by CERN, the European Association for Atomic Exploration, the LHC is the biggest and most impressive atom smasher at any point developed. It is made up of a complex array of detectors and a superconducting magnet ring that is 27 kilometers, 17 miles, long, and is buried deep beneath the Earth's crust. Scientists can examine the tiniest details of the universe's earliest moments thanks to this remarkable device, which can recreate conditions that existed just moments after the Big Bang. The LHC can produce temperatures that are more sweltering than the center of the Sun and make energy levels similar to those present during the enormous detonation. Its role in the discovery of the Higgs boson, a particle that had eluded detection for decades and is frequently referred to as the God particle, is one of its most significant accomplishments. The disclosure of the Higgs boson in 2012 was a milestone accomplishment in material science, affirming a critical piece of the standard model of molecule physical science and developing comprehension we might interpret how particles secure mass. Notwithstanding, with such incredible power comes huge obligation. The capabilities of the LHC raise significant questions and concerns regarding the potential outcomes of its experiments. Brian Cox, a well-known physicist, has recently revealed some troubling CERN developments. As per Cox, surprising discoveries have arisen that could have extensive ramifications. This brings up the basic issue. Might our quest for information at any point incidentally lead us down a way of unanticipated and possibly risky results? The plan of the LHC is a designing wonder. It speeds up protons to almost the speed of light and afterward impacts them with such accuracy that it's likened to shooting needles that are just 6 millimeters separated and guaranteeing they figure out. The machine utilizes 1,232 dipole magnets to control the protons along their way and 392 quadrupole magnets to concentrate them. This is all finished under outrageous circumstances, with the whole framework being cooled to temperatures colder than space, roughly 456 degrees Fahrenheit. This outrageous cooling is important to keep up with the superconducting condition of the magnets and guarantee the machine works at top effectiveness. The impacts created by the LHC are something other than high-energy tests. They are a window into the actual texture of the real world. The outcome of these crashes creates a bunch of particles, and researchers fastidiously dissect the subsequent trash to reveal new peculiarities. Among the most sought-after revelations is the Higgs boson, whose recognition affirmed many years of hypothetical expectations and has opened new roads for research. However, every revelation carries with it new inquiries and difficulties, pushing the limits of our comprehension. The LHC's job stretches out past simple logical request. It goes about as a passage to the unexplored world. We must take into account the broader repercussions of our experiments as we move further into the mysteries of existence. What are the potential perils related with investigating such unfamiliar area? Might our journey for information at some point prompt accidental and horrendous results? The authentic setting of molecule speed increase additionally highlights the dangers implied. Anatoly Borsuk, a Russian physicist, was the subject of a dramatic and potentially fatal incident in 1978, when a glitch at the U-70 synchrotron caused a proton beam to enter his skull. Strikingly, Borsuk made do with no enduring damage, yet the occurrence fills in as an unmistakable sign of the inborn dangers related with molecule speed increase and the requirement for tough well-being measures. One of the main pressing issues with the LHC tests is the chance of making minuscule dark openings. These speculative dark openings would be districts of room with such serious gravitational force that not even light could escape. The idea has sparked a lot of debate and fear, despite scientists' assurances that any black holes that form would be extremely small and decay almost immediately. Questions about the fundamental nature of the universe and our comprehension of space and time are posed by the possibility of such phenomena. The LHC's impact on spacetime's fabric is more than just theoretical. Protons can collide with each other at speeds close to the speed of light to produce energy concentrations comparable to those needed to form a black hole. This peculiarity is essential for the cryptic area of quantum physical science, where the standard principles of reality appear to separate. One of the most prominent figures in theoretical physics, the late Stephen Hawking, warned that the discovery of the Higgs boson might result in high-energy states that could set off a catastrophic event known as vacuum collapse, a sudden transition that could alter the very fabric of spacetime. Sir Martin Rees, a noticeable English space expert and astrophysicist, has likewise communicated worry about the expected risks of atom smasher research. In his book Our Last Hour, Rees investigated the likelihood that high-energy trials could coincidentally prompt devastating results with genuine ramifications. His worries emphasized the importance of carefully considering the dangers of cutting-edge scientific research. The LHC is a symbol of human progress and curiosity, as well as a reminder of the delicate line that separates discovery from disaster. While researchers have directed broad gamble appraisals and reproductions to guarantee the well-being of their trials, public worries about the potential perils are not unwarranted. The broader impact on our comprehension of the universe, the unpredictability of spontaneous reactions, and the ethical implications of manipulating the very structure of reality all merit careful consideration. We must confront profound philosophical issues as we push the boundaries of particle physics. What does reality resemble when seen from the perspective of quantum mechanics? How might we accommodate the abnormal and frequently inconsistent discoveries of quantum physical science with our ordinary comprehension of the universe? All the more basically, what are the results of our activities as we dig into the most profound secrets of presence? The huge Hadron Collider addresses humankind's obligation to investigating the universe's most significant inquiries. It is a machine of unmatched power and accuracy, fit for opening the mysteries of the universe. However, as we approach the brink of discovery, we must remain wary of the potential dangers posed by such knowledge. The LHC is in excess of a logical instrument. It addresses our quest for edification, a pursuit that holds the potential for both gigantic headway and huge hazard. Subsequently, molecule gas pedals like the LHC represent our endeavors to push the limits of science and innovation. They grow how we might interpret the world, yet additionally bring up moral issues.